Now, in this topic, we will discuss the nature of roots. Nature of roots means that how many of them are real and how many of them they are imaginary. So it can be either the roots are real or they are, in other words, are imaginary. We know that p of x is equal to axn plus something is known as to be called a general polynomial there, where n stands the highest power of this polynomial. So n is going to represent the total roots of that equation there. If it has one power, then one root is there. If there is two power, then two roots are there. If there is three power, then three roots are there. And they are going to be classified in the two different categories, real and imaginary, which we can find out with the help of this famous rule, discrete rule. Which in mathematics means change of sign. Now we will discuss this with the examples one by one, and then you will come to know that how many roots are the equation are real and how many of them they are imaginary. Suppose p of x is equal to 2x plus 1. So highest power of this variable is 1 there. So total roots are equal to 1. But whenever there is one root is there, then it is always a real root. Now we will discuss with the help of this discrete rule there. It is plus p of x is equal to 2x plus 1. We see in the terms there is no change of sign in it. So you can write it here, no positive value of x is there. Now we will replace x by minus x, and this will become minus 2x plus 1. And there is one time sign is changing there from minus to plus. So it means it is being used by the negative of x. So one negative value of x, there is one solution of x there which has the negative value to that. For this original equation, if you look at that, p of x is equal to 2x plus 1 if you put it equal to 0, because p of x is the polynomial which is equal to y, and when y is equal to 0, this implies that x is equal to minus of, so there is one negative value of x there. So it means this polynomial has one real root for that possible there. Now, if p of x is equal to 3x minus 1, then you see in this problem that there is one sign is going to be changed, one possible value is there. So you can write it as one positive value of x. Total roots of this equation is 1, and that is already we have calculated it equal to 1 over 3 p of x. If it is equal to 0, then 3x minus 1 equal to 0, or x is equal to 1 by 3. There is one value of x which is positive value which we know in the beginning there. But if we replace it by p of minus x, then this equation will become minus 3x minus 1. X sign will be changed in this form, and there is no change of sign in this part. Minus to minus s, no change. So it means there is no value of x there, or zero value, zero negative value of x there. So that means, in other simple words, there is no change in the value of x there. Now we can find out the next example. P of x is equal to x square minus 5x plus 6. Let's say it is a quadratic equation there. Highest power is 2, so total number are 2 there, which is classified into real and imaginary. We write RE for the real and IM for the imaginary. For this positive sign of x, it is x square minus 5x plus 6. So plus to minus there is one time, and minus to plus there is one time. So there are two values which are positive of x there. When we solve it, we will find out practically that these are the two values of x which are positive values of x there. But if we replace it by minus x, then this equation will become x square minus minus plus 5x plus 6. And there is no change of sign in these terms of this polynomial there. So there is zero value of or no value of x there. The total roots are 2 there, and we calculated it as two positive values of x and no negative value of x there. Now we can simplify it with the simplest example. X square minus 5x plus 6, we can replace it equal to 0 there. X minus 2, x minus 3 equal to 0, or x is equal to 2 and 3. You have seen in this case that there are two values of x which are positive values of x, and they are making it equal to 0 there. We can take the third example. P of x is equal to x square plus 1. Here the total roots of this equation is 2 there, which can be real or imaginary. And the real, we categorize it in positive values of x and the negative values of x there. Since in this equation, P of x, positive x, is x square plus 1, and there is no change of sign, so there is zero value of positive values of x there. Now you replace it by minus x. P of minus x is equal to x square plus 1, and there is again no change of sign, so zero value is of negative there, which is the real root is there. So there is no positive real root and there is no negative real root. Now, because the total roots are 2, so it means the 2 are imaginary roots of this equation there. So this means that it has total number of roots 2 there, and there is no positive real root, there is no negative real root, but there are two imaginary roots for this equation there. Now the new example is there. P of x is equal to x square minus x plus 6. Here the highest power is 2, so total roots are equal to 2, which can be either real or imaginary. They can be either positive or negative. This is in the beginning you have to write down for all the equations given to you. Now you will check it out. How many positive roots are there? How many negative roots are there? If there is no positive, no negative, then the rest of the roots are imaginary. So P of x is equal to x square minus x plus 6. It is plus x. So positive to negative, there is one root, and negative to negative, there is no root. So there is one positive root is there. Now you replace it with the negative value of x. P of minus x, which is equal to x square plus x minus 6. You replace x with a minus x there. There is no change of sign, but positive to negative, there is one sign of change there. So there is one negative value of x is there. So there is one negative value of x is there. Since the total roots are equal to 2 and they have been one positive, one negative, so there is no imaginary root there. Now you can calculate it practically. X square minus x minus 6 is equal to 0. If you replace it by x minus 3 into x plus 2 is equal to 0, then x value is equal to 3 and minus 2. So one there is positive real root, which is positive 3, and one there is negative real root, which is minus 2 there. So this is up till the quadratics, we have solved it with the help of this desperate rule, that how many times the equation has changed their signs, which will be the real roots, and if there is no change of sign, then it will be the imaginary roots. Now we will talk about the cubic equations there. Now let's start for this cubic examples there. P of x is equal to 2x cube minus x square minus 8x plus 4. So total root is equal to 3 there, because highest power is 3. Now this can be classified into this part real and imaginary, positive and the negative. Now P of x is equal to 2x cube minus x square minus 8x plus 4. So there is one time sign changed, minus to minus, there is no sign of change there, minus to plus, there is one sign of change there. So there are two values of x which are positive in this function, and you can see it there that there are two positive real roots of this equation is supposed to be there. Then with P of minus x, it is equal to minus 2x cube minus x square plus 8x plus 4. We change x with the negative x of that. There is no change of sign. There is one change of sign there, and there is no change of sign. So there is one negative real root is there. So total roots are 3, which are already being calculated there. So 0 will be the imaginary root of this equation to this problem. Now we can have another problem of this. P of x is equal to 8x cube minus 12x square plus 6x minus 1. So you see that the total roots are equal to the highest power is 3. They can be either real or imaginary. Real can be converted in the form of positive and the negative values to that. So P of x is equal to 8x cube minus 12x square plus 6x minus 1. You see that there is one change of sign, positive to negative, then negative to positive, there is one change of sign, and then positive to negative, there is one change of sign. So there are 3 positive real roots out there. And if we check with the minus x, it should be equal to minus 8x cube minus 12x square minus 6x minus 1. You replace all x with the minus x there. There is no change of sign, there is no change of sign, there is no change of sign. So there is 0 negative real roots out there. So total roots are already 3, so which are positive. So there is no imaginary root in this equation there. Then we can have another example of this. P of x is equal to 2x cube plus 1. So highest power is 3, which can be either real or imaginary, and they can be positive or negative. Now P of x is equal to 2x cube plus 1. There is no change of sign, so there is no positive real value of x there. Then P of minus x is equal to minus 2x cube plus 1, and there is one change of sign, so it has one real root there. Total roots are 3. One is positive, no positive real root is there, but one negative root is there. So you see that the remaining roots are imaginary. So the imaginary roots are 2 to that equation there. So you have seen in this case that whenever the highest is odd number, then at least one real root will always exist. When n is an odd number, then at least one real root will exist. And when it is an even number, maybe all are real or all are imaginary or some of them are real and some of them are imaginary. But when it is odd number, highest power is an odd number, then at least one real root will always exist there. Maybe all the real roots, but one at least real root will always exist when the highest power is an odd number there. We can have an example there. P of x is equal to minus 2x cube plus 1. So total roots are equal to 3. They can be real, they can be imaginary, and real can be either positive or negative. So P of x is equal to minus 2x cube plus 1. There is one change of sign, so one positive real root is there. If we replace it by minus x, it will be minus plus 2x cube plus 1. And there is no change of sign, so no negative real root is there. The total roots are equal to 3. One is positive real root, no negative real root. So the remaining roots are imaginary in this case there. Now we can have an example of this. P of x is equal to x4 plus 1. So total roots equal to 4. They can be either real or imaginary or positive or negative. So you will see in this case that P of x is equal to x4 plus 1. So there is no change of sign, so no positive real root is there. P of x minus x is equal to x4 plus 1. So for P of minus x, there is no change of sign. So total roots are equal to 4 there. There is no positive real root, there is no negative real roots, and all roots are imaginary. So this is the example of the way that you can find out the total number of the roots, and then you can find out how many of them they are real and how many of them they are imaginary. And from this real roots, how many of them they are positive and how many of them they are negative. This is known as to be called the nature of the roots with the help of this discrete rule. You can proceed it for the further higher power values of the polynomials there.